In last class, we have studied the story of J.J. Thomson, Joseph John Thomson, who gave us the evidence of the existence of subatomic particle electron. And after that, in 1904, he gave us the first atomic model in our world. That atomic model was based upon the structure of plum cake, or you can say on the structure of the inner structure of the watermelon. He said that all the atom has positive charges and negative charges. Negative charges are spreaded like beans or different sliced fruits, okay, just like the seeds of watermelon. So he represented the atomic model like this, and we all know that he was 100% wrong. 100% wrong that atom doesn't look like this. Atom is quite different. How it was different, how internally atom looks like, how it actually behaves was then unknown at that time. There was an incident which I actually shared with you about the death, about the suicide of Ludwig Boltzmann in 1906. And just after that, in 1907, one person came into limelight, and his name was Ernst Rutherford. He got the presidentship of a main laboratory of Royal Society in England. He was the pioneer in nuclear physics. He was the main pioneer in the nuclear physics. He got so many types of discoveries, and he got Nobel Prize for that also. So he was the person who tried to solve the dogma of the structure of atom, how atoms looks like. He got the help from his subordinate officer, subordinate experimentalist, whose name was Ziegler. You will learn about Ziegler in your graduation classes when you will study about radioactivity, because this man discovered Ziegler counter. This is a device by which we can see the very minute elementary particles of atom, because atom is not actually made by proton, neutron and electron. These all are actually made by even minute particles. And what particles are that? How particles disintegrate, what they produce after disintegration, or in the process of disintegration, we can observe those disintegrating particles with the help of Ziegler counter, which was discovered by Ziegler, and which was the person who was a subordinate officer or an experimentalist in the main office of Ernst Rutherford. Okay. So after that, he had been told to do experiment on gold foil. Actually, करने वाले ये थे, but tag goes to the Ernst Rutherford because the idea behind the experiment was his, Ernst Rutherford. So in that time, people were not very aware about the inner structure of the atom, and they weren't very excited about knowing that structure. People were just having had a different methodology in their mind. They still thought that this whole world is made by fluids, liquids, and which are not made by particles. So this was overcome by the collaborative effort of Ernst Rutherford and Ziegler. In the time of 1909, that time, Ziegler had been told to do experiment on a gold foil. A gold foil which was 1000 atom thick, which was 1000 atoms thick. 1000 एटम के जितना मोटाई था उसका, ठीक है. And this thin sheet of gold was shoot by alpha particle, alpha rays. I had told you that in alpha rays The particle which is present is helium nucleus. Helium nucleus. Helium nucleus is the ion, is the particle which create a ray, and that ray is called alpha ray. So alpha ray is the actually helium nucleus beams. So Jigar used alpha rays, okay, and he start hitting that gold sheet. After so many days, after so many weeks, he got nothing. What they saw was an interesting point. When Jigar was doing experiment in the coordination ship of Ernst Rutherford, he saw that mostly all the rays were just passing out from the sheet. Mostly all the rays. This shouldn't be happen, because according to J.J. Thomson, atom is actually fulfilled. According to Thomson, atom is completely filled with plus and minus. According to Thomson, atom is a thick ball, very thick ball. No, there are no gaps in the atom. But अगर कोई गैप नहीं है तो रेस क्रॉस कैसे कर रहा है? रेस को तो क्रॉस करना नहीं चाहिए था. Why alpha rays are crossing? And even these are not photons, these are not electrons, these are very heavy helium nucleus. Helium nucleus which have 2 proton and 2 neutron in a single nucleus. 2 proton and 2 neutron. And these are accommodating the helium nucleus. And so think a very heavy helium nucleus which is actually traveling and actually passing out from a sheet which is already 1000 atoms thick. And even it's the gold atom. And gold atom is actually more heavier. And if it's heavier, then it should be more thicker than helium nucleus. But why all the rays are actually passing? Almost 99.99% rays were crossed from the sheet. 0.01%, around 0.01% were the rays which were showing deflection. They were deflecting in different direction. All the rays were deflecting in different directions. Jigar was intrigued. He thought, what is happening? Why most of the rays are crossing out? Why some of the rays are getting deviated from their paths? What was the reason? Because they actually got something, an evidence which was going to support the idea of the existence of nucleus. But the experiment was going on. Still, Rutherford was unsatisfied. He said one day, he called Jigar and he told Jigar about the experiment. The Jigar said, sir, I haven't seen anything very miraculous. Mostly rays are crossing over. Some of the rays are deviating from their path. What is going on? Most of the rays are crossing. Some of the rays are getting deviated from their path. Why this is happening? Then Rutherford said, Jigar, go to the lab, do this experiment again and see if any particle, if any ray comes back into the same line with which it goes forward. जिस रास्ते से गया है कोई रे, कोई अल्फा particle, so try to observe that if any alpha nucleus is bouncing back into the same path. Jigar was quite pessimistic in that manner. He thought how it could happen, how an alpha nucleus can retrieve its path back into the same way. But he had to accept the order of Ernst Rutherford because he was the chief. So he goes back to the lab and start firing lots of alpha particles to the gold foil. He starts firing lots of alpha nucleus. After so many days passed, nothing happened. After weeks passed, nothing happened. But one day, he got something which was going to change the entire realm of chemistry. He saw that in 10,000 particle, in every 10,000 particle, alpha particle, one alpha particle was seen to going up and returning into the same line. That was great. That was the main thing which happened to be something which was called quite unbelievable. And then Rutherford got the idea of how an atom should be look like. And from there, whole system was changed. How? Let's see. If most of the rays are crossing from the foil, then atom is not fulfilled. Atom must be empty inside it. And so he thought that atom is empty. And in reality, atom is 99.99999999% empty. इतना परसेंट एटम इन एक्चुअल खाली है. First thing clear? From the experiment, first thing was get cleared that atom is not fulfilled like watermelon. It is actually empty. And since all the rays are, some rays are deviating from its path, then there must be a concentration of charges in a place. Concentration of charges means if there is a place in the atom where charges are residing with each other, means charges एक जगह collect होकर के रह रहे हैं, and that point was termed to be a nucleus. Because if the ray has what? Alpha particle, and alpha particle has what? Positive ion. Nucleus is also positive structure, like because nucleus contains protons. So proton has positive charge and alpha particle has also positive charge. So what happened when two positive charges comes close together? So as the alpha particle was coming close to the nucleus, plus repulsion propels the alpha particle to the another direction. So that was the reason behind the deflection of the alpha ray from their path, because nucleus of gold was deflecting the alpha rays from their path. So we got the reason behind the deflection. Now the third part, why the alpha ray, why some of the alpha particles were getting back into the same line. And the reason was, if in a 10,000 alpha particle, one alpha particle maybe was in a straight course, a straight hit course, a straight collision course with the nucleus. And if an alpha particle directly hit the nucleus, it will goes back into the same position. So we got the first model of atom in which there is a nucleus, in which there were protons. Remember, neutron was still undiscovered at that time. Neutron was discovered in 1932, but we are talking about 1909. And Rutherford said electrons are there but in circular orbits. There are circular orbits in which electrons revolve. He said there are orbits just like the orbits of sun in which planets revolve. So Rutherford imagined the atom is just like a solar system. So he imagined the nucleus as a sun and all the electrons like planets which are revolving around the nucleus. And this was the first model of Rutherford, and which is the outcome of Rutherford's gold foil experiment. What was the benefits of this model and what were the drawbacks? We will discuss in next class. Okay? Till then, gracias.